So this tutorial sheet is on one sample test of hypothesis, which we covered last week. You may recall. Yeah. If you look at the review session last week, you will know the stuff that we covered. We covered this stuff last Friday. So. So basically, for question number one, you will need to. Let me show you. You will need to use one of these formulas here. Right? There are 4 different tests, right? So excuse me. You guys can stay here. Yeah. You will need to use one of these 3 different formulas to do question number 1, right? So can you take a few minutes and see if you can have a go at question 1, right? Right. All right, guys, have you done? So let's have a go at question number one, okay? All right, let's change this to top. So basically, you're trying to test this hypothesis that mu is 200 versus the alternative that mu is not equal to 200, right? Okay. And we need to test, excuse me, this is working. No. Right, we're going to use the rule which I just showed you. Okay, before I use the rule, let's write down what is given to us. We are told that the sample size is 40. We are told that sigma, which is the population standard deviation, is 30. And x bar is the sample mean. This, huh? No. That's the 200 is the value that you're testing for. The sample mean is 1 over 40 times the sum of xi. I from 1 to 40. Right? Which is the sum of xi is given here, which is 8.4 divided by 40, which is equal to 208.21. Okay, so this is all the stuff that we know about the question, right? Now we reject the null hypothesis if x bar minus, if you look at the rule that I just showed you a few minutes ago, x bar minus mu 0, which is 200, divided by sigma by root of m, is greater than this is the rule that we're going to use. Okay, do you guys remember this rule? This is, if you look back, okay, let me go back. This is this rule here. This is the rule that I just copied. Okay, right? So let's go back to this. Right, so what I'm going to do now is I'm going to work out the left hand side and the right hand side and see if this inequality is satisfied or not. Right, so let's start with the left hand side. It's going to be 208.21 minus 200 divided by sigma, which is 30, n is 40. Okay, now if you work this out, you will get this to be 1.731. So the left hand side is equal to 1.731. The right hand side right? Now in the question we're choosing alpha to be this or this. There are two different values for alpha, right? So if alpha is 0.05, yeah, then this works out to be equal to 1.96, right? And if alpha is 0.01, right, then this works out to be 0.995, which if you read from the table is 2.576. So the right hand side is either 1.96 or 2.576, depending on the value for alpha, right? And the left hand side is 1.731, right? And clearly 1.731 is not greater than 1.96 or 2.576. So the conclusion is that we cannot reject the null hypothesis. So you will say there is no evidence to reject H0. Okay? Alright, is that clear, guys? Or no? Because it doesn't matter whether alpha is 0.01 or alpha is 0.05. In either case, there is no evidence to reject the null hypothesis. Yeah? Alright, so that's part one. Part two is similar. So this is question one, part two. Part two is similar, so I'm not going to do it. So we're done with question one basically. Can you now do question two, please? Question two. Can you do question two, please? So the first part of question 2 is similar to what we have already done. Okay. Alright guys, so let's look at question 2. Like, okay, if you look in the formulas, right, the question 2 corresponds to this kind of hypothesis where mu equal to something versus mu greater than something, right? So the rejection rule that you need to use is this one here. You follow? Yeah? Alright, so that's what I'm gonna do right now. So to do the first part of question 2. So question 2, part 1. So what we are given is we want to test the hypothesis that mu equal to 0 versus the alternative hypothesis that mu is greater than 0. And what we are given n equal to 10, right? The sample size. Sigma squared is 3, and we are also told x bar is 0.7. This is what we are given, right? And now the rejection rule, we reject at 0 if x bar minus 0 sigma by root of n is greater than z1 minus alpha. Alright, so this is the rule, right? Now the left hand side, let's compute the left hand side. It's going to be x bar is 0.7, sigma is root of 3, root of 10. If you work this out, this will be 1.275. Okay, and the right hand side, we are using 5%, right? Are we not? Yeah, we are using 5%, so alpha is 0.05. So this is 1.645. Alright, so this is the left hand side and this is the right hand side. And clearly 1.275 is not greater than 1.645. So the conclusion is that There's no evidence to reject x here. Is that okay, guys? Hello, guys. Talk to me. Are you okay with this? Yeah. Okay. So let's go to part 2. Part 2 is asking you calculate the probability of type 2 error if the true value of mu is 1 or 1.5. All right. Let's see how we can. I mean, you guys were in the class last Friday, right? So this is question 2, part 2. So we want to find the probability of type 2 error, right? Which is defined. You should remember from Friday last week. Type 2 error is the probability of accepting the null hypothesis when H1 is true. Right? Now, this is the rule. This is the rule for rejecting the null hypothesis, right? This is the rule for the rejecting the null hypothesis. So the rule for accepting will be, instead of greater than, you will have less than or equal to, right? So this will be x bar divided by sigma by root of n less than or equal to z1 minus alpha given mu equal to 1. Right? This is the probability that you want to work out. Alright, now let's put in the values. We know sigma is root of 3, this is root of 10, this is 1.645 equal to 1. Now, what I'm going to do, I'm going to do a trick here. Just watch carefully, okay? What I'm going to do is the following. Because the true population mean is 1, you can write like this, alright? Now, I'm going to take this term here to the right hand side. So this will become the probability that x bar minus 1. You will see in a minute why I'm doing this. Let me explain why. Okay, now you should look at this. Do you know, can you say something about the distribution of this? Can you see what this is? Can you see something about it? Do you know, okay, let me remind you of a result that maybe you forgot this. We did this a long time ago when I talked about the normal distribution. One of the properties I gave you is the following. Okay, this is one of the properties I gave you. So, I don't know whether you remember this, but if you don't remember, just please look back on the video on the normal distribution, right? That is, if you have a random sample from a normal with these parameters, then this guy here is standard normal, right? So I'm going to use this. So condition on mu equal to 1, this guy has a standard normal distribution. So the next step is to just simply write this, right? You see what I've done? Now you see that I have removed the conditioning disappears because condition on mu equal to 1, this has the standard normal. So we have used the conditioning. and therefore we don't need to put the conditioning anymore. Okay, so I have removed the conditioning here. So this becomes phi. Remember, phi is the notation for the CD of standard normal. And if you work this out using a normal table, this is what you will get. So 0.43. So this is the probability that of type 2 error. In other words, it's the probability of accepting the null hypothesis wrongly when H1 is true. And similarly, you can do it when, so in this case I have done it for mu equal to 1, and you can also do it for mu equal to 1.5 similarly. Alright? So I'm not going to do it. Is this clear to all of you or not? Any questions, please? And you should just please don't be afraid to ask questions. Alright, that's part 2. Now part 3, there's a part 3. Part 3 is to, assuming that the sample mean remains the same, how large should the sample be in order for H0 to be rejected in favor of H1? Now how would you do this question, guys? How would you do part 3? So it's basically asking you, this is the rejection rule, alright, this is the rejection rule. So in other words, it is asking you what n should be such that this rejection rule is satisfied, right? So let me show you how to do it. So this is question number 2, part 3. The rejection rule is that x bar divided by sigma by root of n is greater than Z1 minus alpha, which is the same as saying that x bar is 0.7, sigma is root of 3, n we don't know, and this guy is 1.645. Right? Okay, so this is the same as saying that 0.7 times root of n divided by root of 3 is greater than 1.645. Right? And this is the same as saying that root of n greater than right? And if you square both sides, this will be n. Are you guys okay? Come on guys, listen to me please. So this is what you will get. And if you work this out, I don't know whether I have the answer here, but if you work this out, this will be equal to 16.5675. But n must be an integer, right? It cannot be a decimal number. So the smallest, so n must be greater than or equal to 17. Alright, so the smallest sample size, so that this rule is satisfied is 17. Right? Okay guys, is that clear or no? No guys, are you okay with that one? Can you do the next question 7 please? Question 7 in the problem sheet, which is the last question. So let me put this away. So we've done question 1, we've done question 2. Can you have a go at question 7 please? Question 7. So this involves proportions. So let me show you, sorry, here we are. You should go to the website. The rule that you need to use are the ones on this page. So use this page to do question number 7. Yes. No, it's five is the sample proportion. So what's the sample proportion here? We have 47 out of 410. So what's the proportion? Yeah, that's right. Good. Yeah. No, you have been told that P equal to 0.1, so that means it's the same. Yeah, it is correct. Okay guys, have you done the first part? Let me show you if you haven't done it. I know some of you have done it. So let me show you the first part and then part 2. Okay. So this is question 7. Question 7, part 1. Oh, let me change the camera. Oh, sorry. Doc. All right. So we are testing P equal to 0.1 versus P not equal to 0.1. And we know the rule for rejecting is we reject H0 if all right. This is the case, right? Okay, now let's compute the left hand side, which is going to be x bar, x bar is the sample proportion, which is given to you as 47 divided by 400. Yeah. And if you work this out, this will be 1.66667. I'm sure you got this right. And the right hand side is, we are using 5%, right? 5%. So the right hand side is 0.975, which is 1.96. So clearly, the left hand side is not greater than the right hand side. So the conclusion is that there is no evidence to reject the null hypothesis. So you will say all right, guys. So I'm sure all of you are fine with this. Any questions? All right, let's look at part 2. Part 2 is asking you to find the approximate probability that you reject H0 and the true value of P is either this or this. So I'll just do the first part, only one of the values. So we want to find the probability of rejecting H0 when, say, P equals to, okay, yeah, right. Now we know the rule for rejecting. All right. Okay. The first the first thing you need to do is to get rid of the absolute sign. I'm sure all of you are experts in math. How do you remove an absolute sign? Like if you have an absolute sign, something like this, how do you remove it? I mean, if you have something like, say, absolute value is z greater than, say, a constant a, then that's the same as saying that either z is greater than a or z is less than minus a. I'm sure you know this. Have you seen this somewhere? Yeah? Okay. You know this, right? So I'm gonna use this fact, and okay. Alright, now these two events are mutually exclusive. In other words, they cannot occur at the same time. That's what mutually exclusive means. I'm sure you did this in probability 1 last semester. So if you have a union of two mutually exclusive events, then the probability of their union is the sum of the probabilities. Right? So you can write this as okay, you can write it like this. Yeah, now the next step, what I'm going to do is because the true proportion is 0.103 and not 0.1, I'm going to change this guy and this guy to 0.103, right? I will do that as follows. So I'm going to change this guy to 0.103, right? And because I've done this, I need to add this, okay? You see what I've done? Okay. You have this, right? Alright, in the next line, what I'm going to do is I'm going to take the third term, that is this term, and this term to the right hand side of the inequality. You'll see in a minute why I'm doing this, okay? So if you do that, you will get Okay. All right. Now, this is where the crucial part comes in. Now, if you look at this term and this term here, condition on the true population, the true proportion being 0.103, these two terms have an approximate standard normal distribution. And where does it come from? If you look at the notes on binomial distribution, which we did long time ago, you may have forgotten by now, but if you look at the review notes or the printed notes, typed notes on the binomial distribution, you will see this result, that anything looking like this, where this is the true proportion, that is 0.103, has an approximate the distribution of these can be approximated by standard normal, right? So that's what I'm going to do in the next page. So let me extra page here. So in the next line, in the next line, so this is an approximate statement. It's going to be P n01 greater than 1.96 Okay, once again, I'm going to remove the conditioning because we are using conditional on the true population proportion being equal to this. This has an approximate standard normal, and similarly here, right? So we have used the conditioning. So we don't need to use the conditioning anymore, right? I'm running out of ink, I guess. Sorry. My pen has run out of ink. Sorry, guys. Alright, this is what you will get, right? And in the next line, this guy here can be written as 1 minus phi or phi yeah, and this guy here can be written as phi right? Okay, and if you work this out using a calculator, this is what you will get. You will get this to be equal to 0.058. Alright, so that's the answer. That's the probability of rejecting the null hypothesis, and the true population proportion is 0.103. And similarly, you can work it out when the true proportion is 0.105 is similar. It's very similar. So I'm sure you can do it. Right? So, yes. Questions?
Where do we know this function is standard?
Yeah, you look at the stuff from the binomial. Should go to the binomial distribution. I'll show you. Okay, I think that's a good question. Let me show it to all of you so you can see. I think the question was, the question the gentleman asked was, where can we find that this has an approximate standard normal, right? Let me show you where it is. You should go to the stuff that we did on binomial. This is the stuff on binomial we did ages ago. Not this one, no, not this one. I mean, on the central limit theorem stuff. This. It's not quite here, but basically I'm using the central limit theorem. I'm using the central limit theorem with for a random sample from a binomial distribution, from a Bernoulli distribution with these parameters. So let me write it down. If you have right, let me right. Okay. All right. This is the result I have used in the example that I just did. Right. That suppose you have a random sample from a Bernoulli with parameter p, then the expectation is p and the variance is